we're getting into pretty difficult maths. So, Pythagoras Theorem is the introduction to a field of maths called trigonometry, which trigonometry is a part of geometry. Now, if you're wanting to get into a field of engineering, trigonometry is a very big part of engineering, especially for mechanical engineering, because and civil engineering. Because let's say you want to build a bridge, and you have to find out what the supports are and the forces acting on each support, so that you have a stable bridge, so that cars it's a pretty cool car, so that cars can go over the bridge without it collapsing in the middle or without it breaking. So in Pythagoras Theorem, we deal with triangles. Most importantly, we deal with right-angled triangles. So Pythagoras Theorem only deals with right-angled triangles. So this is what you call a right-angled triangle. The way to identify a right-angled triangle is if it has this little box in the bottom left. This is a degree. It's measured in degrees, which looks like this. The little circle above a number. But it's not talking about the temperature. Temperature. It's not talking about temperature. It's talking about angles. So what this box is saying is it's saying that if you think of a circle and you divide it into 4 pieces, if you take this, so a full circle, if you go around the full circle, that is 360 degrees. So if you divide 360 by 4, this equals 90. So this little square here is 90 degrees, and that's how you can identify if it is a right angled triangle or not. So we got a bit sidetracked because we'll get into that once we get into trigonometry. But let's say we have 2 sides. Let's say this side is 3 meters. And let's say this side is 4 meters. What is x? So we have a formula for Pythagoras Theorem. The formula is, if I can go back, the square root of a squared plus b squared equals c. So let's call that c. This side is c. So we have to identify what our sides mean. So I'm going to draw a line for the C line. In trigonometry, this is called the hypotenuse. Good way to identify the hypotenuse is if the corner of the box is pointing at the line. So what the Pythagoras Theorem says is that this line, I'm going to draw it in a separate color, so let's do blue. This line here right here, that is what we call the opposite. And again, I'll get into this once we do an introduction, once we do a full introduction to trigonometry. And this side here, the green side, is what you call the adjacent. So now we have our sides of the triangle. So let's explain. So if the opposite, so let's say the adjacent equals B. The opposite equals A. So we have our A side and our B side. So what this equation is saying is that if we have A plus B, it's the square root of A plus B. Let's get rid of this square root symbol. So if we say A squared plus B squared, this will equal C squared, because A plus B equals C. So if we have one side, let's say we don't have B. So that means we have C and we have A. So C is our longest side, It is the hypotenuse. The hypotenuse is the opposite plus the adjacent. You cannot have the adjacent larger than the hypotenuse, the adjacent larger than the hypotenuse, or the opposite larger than the hypotenuse. If you add both the adjacent and the opposite, it'll be larger than the hypotenuse. But if they are smaller than the hypotenuse, then it cannot be a proper right angled triangle, and that's when you're dealing with either an equilateral triangle or a scalene triangle, which sort of looks like that. So let's go back to our equation. So we have our terms. We have the opposite of A. So we have A as our opposite, which is 3 meters. So if we substitute, which means we know our A equals 3. So that means our 3 will be our A, plus our B, which is 4 squared. If we expand that, so 3 squared means 3 times 3, which equals 9. Our 4 squared is 4 times 4, which equals 16. So if we add 9 plus 16, we will get 25. So 25 equals our C squared. But we have to get rid of this. So I should do that in a different color, or I should just do one circle. So we want to get rid of this 2, this this squared. So to reverse a square, we must do a square root. So that means we'll do the square root of c squared equals c. Oh, square root of 25, sorry. 25 equals c. So the square root of 25, if you go 5 times 5 equals 25. So the square root means that you are basically dividing it by its own number. So you're dividing it by 5, which will give you 5. So c equals 5. And just to briefly introduce trigonometry, in a right angled triangle, you will have an angle, theta. So theta, maybe not a line like that, theta equals, it could equal any, let's say, x degrees. So theta could equal anything, any degree, as long as theta, and this is what you call alpha. So as long as theta plus alpha equal 90, then you are dealing with a right angled triangle. Because if we have 90 here, and let's say this is 45 and this is 45, then these two add up to 90, and plus this right angle, plus this 90 degrees, which will give you 180. So every triangle's angles will always add to 180 degrees. It's quite a difficult, bit hard to understand, but if you have a calculator, I want you to do these questions. So let's say I'll give you 2. That was quite bad. So let's say this is 6, and this is just trying to think. Oh, this is 6, this is 8. What is C? For our second problem, you're trying to find A. So this is, let's say this is 10, and this is, no. Let's say this is 10. Let's say the hypotenuse is 10, and your adjacent is 8. So what is A? I'll give you a hint. If we go A squared equals C squared minus B squared. And remember, you need to get rid of this squared symbol. So in order to get rid of it, you square root it. You can find it on most calculators. Oh, pretty much on every calculator you'll find the square root symbol, which will give you A. Okay.